All right. Okay, cool. All right. That was what I was mainly looking for, was my slides. So I'm glad we have them. So I'm David Luan. I'm one of the co-founders of a company in New York City called Dextro. We're based in Soho, and we provide very simple computer vision APIs for anybody to analyze the contents of video. So this talk is going to be about the key technical challenges that we faced when we moved towards analyzing countless hours of video in the wild. So focusing primarily on real-world video understanding. So just as some background for some context on who we are, we're a computer vision company whose sole focus is actually working with video. Around 300 hours of video, that's probably even more now actually, are uploaded to YouTube every minute right now. And all of these, just YouTube alone, for example, and these companies are essentially drowning in content. So what our company was made to do was to just make it really easy for content owners to basically, one, understand their videos, two, make their videos easily discoverable, and also be able to analyze how their audience would potentially react to it. We do this by analyzing each video to extract the key brands, objects, and scenes that appear over the course of a video. So our system supports thousands of commercially relevant objects and scenes and concepts, along with almost all of the top brands by advertiser presence in the United States. So what we do is we turn these low-level cues and turn them into a whole video summary of what happens in a particular video, according to whatever categorization scheme that our partner may want. So our partners can use this to quickly power, for example, video categorization, video recommendation, discovery of videos, or also just filtering out content. So what we do is we provide what's also a salience graph, which is a discounted score of how important every concept or prominent a particular category is over the video as a whole. So it's not a measure of our confidence, but of actually how important was this theme over the course. So if, for example, a pair of shoes pops up for a second, it'll have a very, very low score on this particular metric. And we also provide a simple timeline of timestamp information about what's appearing on screen when. So partners can use this in the editorial process to slice and dice to exactly whatever particular segment in a video they want to extract or highlight or show off or link to as the case might be. But all these are just visualizations. Is this coming out? All of these are just visualizations. The graphics in the previous slides are just that. But to be developer friendly, our API just responds simply with JSON. As a result, it makes it really easy for us to integrate with video CMSs, asset management systems, and as well as any custom backend that a developer may want to write. I was hoping to actually show a live demo today, but as you guys all know, the main caveat with live demos is that they rarely tend to work when you need them to work. So I'm actually going to show some recent work of ours. What we basically did was we originally started out with productionizing video back in 2014. We were the first company to figure out how to get this level of analysis of what's happening in videos as a service. And after that, actually, just 2 weeks ago, we launched the ability to analyze live streaming content as well via API. So you send us a link to any live stream, whether that's Periscope, Meerkat, HLS, RTMP, and we stream back chunk JSON of what's happening in that live stream in real time. So we built a demo site that basically takes every public live Periscope stream, feeds it through our system, and essentially shows at a glance exactly what's happening on Periscope at any given moment. So some of the pretty crazy things that we caught were, for example, we were able to pick out protests as they happen in our crowds category on Periscope Live in real time, to other things like for example, where did it go? For example, hockey games as they are happening live on Periscope. And this is all just done with computer vision. We don't use any of the metadata whatsoever to identify what's actually happening. And being able to do everything live in real time was a major scaling challenge that we worked on to be able to do that. Other kinds of things, I can just keep on pulling these up. We have lots of different types of all of these classifications that we're able to do on live video in addition to pre-recorded video. And it actually all works the same for the developer at the end of the day. So this was so it's as a result of doing this all with computer vision. It's language agnostic. We don't need to use any of the metadata, and we can generalize to any particular language or country without needing to do any further work. And so this was covered in Wired, Fast Company, and the Next Web, amongst other places. So how we help is basically we make it really easy for sites with lots of users who are watching videos to be able to easily discover great content and to be recommended great content on their site by actually figuring out what's happening in the video itself. We also enable editorial teams to be able to easily go through new content and be able to find interesting breaking news content or to curate what's the most interesting things to show on their site. And 3, given the very video-centric nature of what people are doing on the web these days, we make it much more easy to learn about what your audience is actually interested in because we're able to determine what these people are actually watching inside the videos themselves. But now that you know more about what we do, I wanted to kind of talk more about the challenges of real-world video analysis and how we kind of got to where we are now with regard to our core systems. As I'm sure all of you guys know, just like given a lot of the popular media coverage around this, computer vision right now is advancing at the fastest pace it's ever been. And a lot of that's driven by the latest advances in deep learning, which is something that we use extensively at Dextro. You guys are all data people, so I'm not going to spend too much time going over the history part of this, but quick recap, just a few years ago, most of the cutting edge work was actually done in scene object and concept identification was simply just by hand tuning a bunch of features and putting a classifier on top and seeing how far we could get. But in 2011 and 2012, we really saw this change in a really big way. A big major notable milestone was Krzyzewski's work on ILSVRC, which is the ImageNet large-scale visual recognition challenge, where in 1 year, essentially, they blew away the previous state-of-the-art with a deep convolutional neural network by about like half of the final error rate on the entire set. And this was just a really big milestone. That's when most of the public interest in the field kind of happened. And just a few months ago, the main general interest thing that was shown was when at Stanford, Karpathy's group, they did automatic image captioning by simply hooking up a convolutional neural network to an RNN to get something as complicated as 2 young girls are playing with a Lego toy out of this particular image. And this just all happened in the last few years. So essentially we went from very mediocre high-level classifiers that took features that didn't really generalize very well to some pretty crazy, occasionally human-level feeling results. And the possibilities just seemed to be endless. It seemed like every day somebody was blasting through an existing machine learning record just by throwing deep learning at a particular problem and seeing what happened. It seemed like you could beat or at least match the quality of hand-engineered features with relatively little effort. And actually, for a while, people were just publishing lots of papers that were applying deep learning to new fields and getting them through. And I think the reviewers now are pretty tired of that, and they're moving on. And so deep learning has been applied to speech, video games, protein folding, stock trading, and all manners of things. And even when you just scope the computer vision, there's actually still tons of different use cases, whether that's analyzing medical imagery, multispectral imaging, satellite imagery, or finding defects in manufacturing. All of this is still within the realm of just applying that to computer vision. And so on this very exciting frontier of what's possible, it really feels like you could and should do everything. And that's what our first challenge was. As a computer vision company, it didn't originally appear to us to be a challenge, but that was choosing where we wanted our video understanding systems to focus on. Because the potential is both a blessing and a curse. Because the deep learning methods have shown so much promise, it's really tempting to commercialize the means, which is the algorithms and the classifiers themselves, as opposed to the end, which is solving the actual customer problem of whether that's video discovery or whatever that ends up being. And so as a machine learning method, it's done a great job of getting us 80% of the way there on a lot of different problems. But in most cases, customers aren't willing to pay for a product that only gets them 80% of the way. You have to kind of like specialize and focus on the problem to make sure that you get to being 100%. And the other part is, the big promise of this is that the more customers you work with, the more data points you have, and the more shareable the learnings of your classifiers are over the entire customer base that you have. But when you cast too wide a net with a machine learning platform, for example, if we did all the different areas above that I just showed in the previous slide, that no longer holds because each one of these different verticals is a different data silo that's no longer shareable between all the different customers that you might have. So for us, after talking to tons and tons of customers, we realized that the repeatable opportunity was in understanding real-world video, which we've broken down to essentially cover the highly overlapping areas of entertainment, user-generated content, and news. So we decided to build a comprehensive knowledge base of what real-world, commercially relevant concepts look like in these particular areas, since they all essentially commonly share them. Now that we're on the topic of training data as well, the next challenge that we had to deal with was going through real-world content versus iconic images that you might find in a stock photo setting. So for example, a lot of the large-scale visual classification work that was done, and a lot of landmark results were on ImageNet, which were basically created by going to Google image search and searching for example, a laptop or whatever other keywords that you might find to build a training set of photos. But these images are what my friend T.Y. Lin at Cornell Tech calls iconic images, because they're object-level images usually centered in the frame, posed, and in an uncluttered environment. The work done on this is fantastic for the field, and a lot of the pre-training areas are super interesting. But it's not the right problem at the end of the day, because at the end of the day, what you're looking to do is extract meaning out of videos that look like what we show in the real-world section. And classifiers and models that are trained and tuned on this particular iconic type of data don't really generalize as well when you apply it to something that you might see in a real-world video like on YouTube or on Periscope. So we had to build systems at Dextro that were specifically meant to collect real-world data that look like this for training examples, and also to build models that would work much better on this much harder real-world data. The next challenge we faced was, how do we move past tagging? Tagging is supremely useful for digging up interesting combinations of objects or low-level concepts in like a stock media use case. But we learned really quickly that for potential users of our product when we were originally starting out, that were focused on like discovery, curation, aggregation, and all of these different use cases, video or frame-level tags of the sort that you might see that I've put on the screen right now didn't actually solve their problem, because it was too low level not in terms of a granularity sense, but in terms of how much additional information it added about what was happening in the video as a whole. So what they really wanted to know, like for example, to power discovery on like a major media site, was how do you actually understand what the whole video is about? How do you understand what the scene is about? And what they really wanted to see in this case, for example, would have been dash cam of a truck crash. It wouldn't have been like sunny road, trees, green grass, highway. And so that moved us on directly to building out an easy way for us to generalize our system to multiple different partner taxonomies. Because partners usually knew what they wanted to see out of their content. They generally had either an internal taxonomy of how they arranged and organized their media, or they used one that already existed, like the classic standard IAB Tier 2 categories inside online advertising. And so our system, our core machine learning system, needed to be able to easily adapt and generalize to customer and partner taxonomies without restarting training and data collection and everything like that from scratch every single time. And so how we solved that problem was to essentially build infrastructure that let us turn our training data and morph it and group it in easy ways to be able to obtain the desired partner taxonomies on demand. Last aspect I wanted to touch on was building video-specific models. Most of the academic work until very recently actually has primarily focused on classifying photos and on assigning like one major label to a particular photo. And so of course the naive approach to generalizing to video is to analyze videos as just a frame-by-frame sequence of photos. But there's so much encoded in the motion information in a video that to just do that actually just throws all of it out. And so by doing that, you do two things. One, you don't use information that you could have actually used to improve your overall classification accuracy. And two, you're turning the computational intensiveness of the problem up even higher than you actually need it to be, because a lot of information, motion information, though useful, there's still a lot of redundancy that's happening. So we've actually spent a lot of time building a deep learning model specifically that can encode the motion information and actually take into account in the classification phase. And another nice byproduct of that from an actual customer use case perspective is that we can actually tell what segments of the video are about. Like not just what a video is about at an instantaneous moment, like you might be able to do with a frame by frame, but actually to say this particular region of the video is about, for example, a dash cam of a truck crashing on the highway. So yeah, these are a sampling of some of the problems that we're solving at Dextro, and I guess right now for us, having solved a lot of these key technical problems, we're mainly excited to continue growing our partnerships and to kind of take that and move that back into how we can continue tackling other interesting problems from a data perspective. Does anybody have any questions?
Thank you very much. I have perhaps a random question. Is there a world where at some point you can do predictive analytics on video, so you get so real time that if you have a soccer player, you can predict in real time where they're likely to go, where the ball is likely to go, or in a video camera, whatever, traffic analysis. Is that the type of world we're heading towards?
That's a fantastic question. We haven't thought directly about using this for predictive analytics, but right now with the latest launch of our live stream API, we actually are able to analyze any live stream in real time and stream back JSON of what's happening. So it definitely could be used for that scenario. I'm just a little bit bummed that the particular live demo I wanted to show of that live stream product happening wasn't able to be up today to show you guys that.
Great. And other question, and then I'll pass it on to people here. Another sort of futuristic thing, is there a world where deep learning becomes a truly sort of horizontal AI layer? You touch upon this a little bit, but what would it take to go beyond sort of this vertical by vertical approach and have this one utility that sort of answers all questions? Or how far are we is that complete science fiction, or is there a world where that happens?
I think there's definitely a world where that happens. The world's not quite 2015 summer. I'm not quite sure exactly when that might be, but there's a lot of interesting work going on right now with essentially combining multiple domains of solving a particular problem to get way more insight on the problem as a whole. And models like that are continually just getting better over time could potentially be like that in the future. But at the same time, I think that it's important for us to draw a distinction between deep learning as a machine learning method versus the specific in terms of a commercialization and helping partners standpoint, drawing a difference between the machine learning method itself and the remainder of the last mile work in terms of both data collection and fine tuning that actually gets you something that solves customer problems really well. So I think that in terms of where we're going to see it in industry, it's likely to be still in a kind of vertical by vertical system for a little while before we start seeing a little more convergence.
Great. I want to open up to questions. All right, Luan, since you raise your hand first.
Richard Blue, hi. Can you just talk us through what kind of hardware you have to throw at this problem to be able to do live processing? Is this GPU intensive, or what sort of systems?
Great question. It's definitely very GPU intensive. When we launched our demo site, which basically crawled everything on Periscope that was public and posted to Twitter, like the sheer number of streams that were concurrently happening at any given time was a major challenge for us in terms of an optimization perspective to how do we make this something that we can actually afford to run and be fairly cheap. And that's that we've been able to do because we've put a lot of effort into our video specific models. But it's all of our everything we've built in-house in CUDA for NVIDIA GPUs. So we have a little farm. We have like two halves of that. One we use in production to service customers, which is just normally as a cloud hosted, and then we also have a cluster that we built on site that we just continually run training on to keep our models fresh.
Good. Andrew, you have a mic?
Are you able to include sound into your model to help classify certain things like truck crash, for example?
Let's talk in a couple months.
Can you find the locations, like the GPS coordinates and things like that, from where the video is being taken?
Currently, we're working with the visual data alone, which gives us a lot of benefits, like, for example, being language agnostic, which is super important for user-generated content. So with regard to using things like GPS coordinates, if it's passed to us in the metadata, it's something that we will pick up. But we currently don't do anything like, for example, matching the background of a video to, like, this is this street corner in Paris.
Eric Smith, hey. So I was wondering, could you use some existing repository of videos, say YouTube or whatever, that might have some user-generated tags in order to kind of provide like a training for your extracted salient features?
So with regard to using tags that are already present on the internet, we run into a bunch of different problems, which is that one, so there is some information to be gained there in general, but it's extremely noisy, and Another big thing that we see is a difference between editorial tags of like how would an editor looking at this piece of content figure out what's most salient and what's actually visually prominent. And so as a result, they're correlated, but they're not so well to the point where we could just directly use that to train.
Thanks, Andrew.
Thank you. So I guess the next natural question is, how do you train? Like, how do you construct your training set, to the extent you can tell us?
Sure. We've spent a lot of time, as I touched on briefly in the presentation, the natural and obvious thing to start with is basically to ingest, for example, like all of the iconic images, because they're very easy to get access to. But for us, we have spent a lot of time building out custom data pipes that let us hook up to real world content where, for example, we're looking at more cluttered scenes, we're looking at objects in context. One thing that I'd love to point out is that like we're lately starting to see a lot more work being done in this space as compared to the pure iconic work. And one data set that I think is really good and representative of a lot of our philosophy is T.Y. Lin's Microsoft Cocoa set, which just came out a couple of months ago. So if you're interested in that area, I definitely recommend checking out the Microsoft Cocoa set.
Those are great questions. We have time for a couple more. Over there.
Hi. So in natural language processing and speech recognition and so on, there is the whole idea of a language model that is given certain words that occur, what's the probability of the next word occurring. Do you have something analogous to that, which one might call a world model? And I think that may be related to Matt's question, which is predicting what's going to happen next, right, in a frame. You see several frames, you interpret them in a certain way, and then for the next frame, you use some kind of a world model to help you interpret that. Do you have anything like that?
That's a great question. So right now we haven't actually productionized anything that lets us extract the output of the prediction of what happens next. Could be something interesting to look into for sure.
Hi, I'm Lydia. I so much enjoyed your talk. So one of the major problems in home health care, for example, is that you have older people who fall. It's the major health risk. Bar none, it's a major cost of medical care, probably over 80. So I'm looking at Matt's question and that gentleman's question. I'm thinking, if you could take video streams of people in their homes and predict in a sense what are fall risks and how far from deviation those people are from potentially falling, it's an incredible market because there's a huge push towards people staying in their homes. And to capture that specific medical risk, which is outside of any range of healthcare costs, would be something that I think would be a very interesting application of your system.
Yeah, I definitely think so as well. It's not a market that we've yet really looked at very much, but it seems like something we could potentially help in at some point.
Your learning models would be very interesting, right? Because you can both do the same stream of the same person over and over, plus the fact you had a huge amount of aggregated data.
Especially with the rise of all the canaries and white things on like all the home cameras.
Yeah, definitely.
Obviously drop cam. All right, one last question, whichever one you're closest to.
Thanks. I'm really excited about the deep learning on streaming video, and I think we're getting close to something. I just want to know how applicable would that be for streaming sensor data? Like if you had location traces of thousands of people in one city at once, could you apply streaming video deep learning to recognize certain citywide context or something like that? Or how different do you think the models would have to be for streaming sensor data as opposed to also applicable for what she was talking about with wearable sensors where you could detect the fall or predict loss of balance?
Yeah, that's a great question. So my personal experience has actually entirely been on photos and videos, and I actually haven't spent a lot of time generalizing to other sources of information. I almost wonder in certain cases whether or not it might actually be overkill. But definitely something that totally recommend that you could play with by using one of the open source libraries that you might be able to get started with some things that aren't video specific. for sure. But yeah, so with regard to the streaming video stuff, if you guys have time after the talk, tomorrow we're just ironing out that one issue, but you guys should all check out stream.dextro.co, which aggregates every live public Periscope stream, and you can kind of browse based on what you think is most interesting at any given moment to discover like live protests or dash cams or whatever it is you want to see. Thanks.
All right. Well, thanks very much, David. That was awesome. Thank you.
Thank you.